and welcome to Chapter 2, Reasoning with Data. So in this lesson, you are going to learn to define reasoning, execute deductive reasoning, explain an empirically tested solution, execute inductive reasoning, differentiate between deductive and inductive reasoning, and explain how inductive reasoning can be used to evaluate an assumption and describe the selection bias that might occur in inductive reasoning. So reasoning is the process of forming conclusions, judgments, or inferences from the data or the facts. Reasoning and logic are often used interchangeably. Logic is a description of the rules and or steps behind the reasoning process. So here we presented with two arguments. Argument 1, the company's profits are up by more than 10% over the past year. An increase in profits of 10% is a result of excellent management. You were the manager over the past year, therefore I conclude that you are engaged in excellent management over the last year. Argument 2, 10 of your 300 employees came to me with complaints about your management. They indicate that you treated them unfairly by not giving them a raise that they deserve. Therefore, I conclude that all of your employees are disgruntled with your management. And these are actual arguments that can happen in business, trust me. So understanding reasoning. In presenting the two arguments, the goal is you can't really make a definitive decision about which you believe, if either one you believe. The goal is to think about and distinguish between the different lines of reasoning. And in distinguishing between these different types of reasoning, you will hopefully be able to establish why you believe or question the claims made within the two arguments. So we have two types of major reasoning. We have deductive reasoning and inductive reasoning, and both play an important role when we're interpreting and drawing conclusions, especially from data analysis. So let's start with deductive reasoning. Here we're going from a general topic to a specific one. It's also known as top-down logic, and it seeks to prove statements like if A, then B. So this type of reasoning implies three underlying components. You have if A, which is assumptions, methods of proof, then, and the conclusion, B. So that our assumption would be if A, our method of proof would be then, and our conclusion would be B. So deductive reasoning, the purest applications of deductive reasoning are typically in math, right? So you have two of the most used approaches are direct proof and transpositions. So direct proof is a proof that begins with assumptions, it explains the method of proof, and then it states the conclusion. Transpositions are any time a group of assumption implies a conclusion, right? Then it is also true that any time the conclusion does not hold, at least one of those assumptions may not hold. So let's prove the following statement by a direct proof. If we have x and y are odd numbers, then their sum, x plus y, is an even number. So if x is odd 5 and y is odd 9, you sum them, 14 is an even number. So failing to find a contradiction is not the same as proving a statement is generally true. So a direct proof from a mathematical approach is if x and y are odd numbers, then their sum is an even number. We would say x and y are odd numbers. If x is an odd number, then x can be written as x equal to k plus 1, where k is an integer. So you would see 2 times 6 plus 1 is 13. If y is an odd number, then that can be written as 2m plus 1, where m is an integer. So in this case, we might have 2 times 11, which equals 22 plus 1, gives us 23. Then you would have x and y, with taking the 2k plus 1 and the 2m plus 1 to get to k plus m plus 1 is an integer. So x plus y is 2 times an integer, and any number that is 2 times an integer is divisible by 2. That means x plus y is even. Now let's talk about a direct proof using a common sense approach. So if McDonald's offers breakfast all day, their revenues will increase. McDonald's stores offers breakfast all day. The addition of breakfast during the lunch and dinner hour implies more choices. Customers already choosing McDonald's during lunch and dinner hours can continue buying the same meals at McDonald's, but customers not choosing McDonald's during the lunch and dinner hours may start eating at McDonald's, and retaining these current customers and adding new ones, then McDonald's will increase revenues overall. Now let's talk about transpositions. While direct proofs are sufficient to prove a point logically, an alternative approach is that of a transposition, and this may be more effective. It's the equivalence between the statements if A then B and if not B then A. So anytime a group of assumptions implies a conclusion, then it is also true that anytime the conclusion does not hold, then at least one of the assumptions may not hold. So if A, then B, but if not B, then not A. And here, if we prove the statement, if x to the second power is even, then x is even, suppose x is not even a number, instead is it an odd number. And if x is an odd number, then x equals 2k plus 1, where k is an integer. Then we get x2 equals 2k plus 1 to the second power, 4k to the second power, 4 plus 4k plus 1. So we go through all of these formulas at the end to get that we're meaning of an odd number. So if the statement, if x2 is even, then x is even, using transposition, the opposite of the conclusion is used to prove the opposite of that assumption. If x is odd, then x to the second power is even would be incorrect. So transposition can also be used without using any type of mathematics. So if A, then B. And transposition can be particularly effective if the assumption seems like indisputably obvious. So let's go back to our McDonald's example with a transposition. So if McDonald's stores offer breakfast all day, revenue will increase. McDonald's stores revenue will not increase. This means total revenues from current and new customers will not increase. This means either that there will be no new customers or revenue from current customers will decrease. This means there could not be an expansion in the menu. McDonald's stores do not offer breakfast all day. So direct proof states assumptions, explains methods of proof like mathematics or common sense, and states conclusions. Transpositions, they assume the opposite of the conclusion, explain methods of proof, same thing, math and common sense, and state assumptions that are violated, such as this is not X. So in deductive reasoning, this is used commonly in the application of law. So if there's a disagreement with a conclusion, or there are two possible sources, we have the method of proof or the assumption. And there are two ways of resolving disputes about assumptions. Show robustness, the persistent accuracy of a conclusion despite variation in the associated assumption within the context of a deductive argument. Another way to resolve disputes about assumption is to assess consistency within a collected data set. So we want an empirically testable conclusion. So an empirically testable conclusion is a conclusion whose validity can be meaningfully tested using observable data. So a banana company's management staffs are divided into two groups about their product's placement, let's say in a major grocery store. So group one believes the change in the current location will increase its sale, while group two believes that the current location is good enough. So the company has the sales data for the current location, and the company chooses to move its product to a new location and collect that sales data. Now that company has a meaningful test, the validity of the management's competing conclusions. So making the actual decision about the validity of an empirically tested conclusion based on observable data is an application of inductive reasoning. So inductive reasoning is where we go from the specific to the general. So we're using a bottom-up logic. So the entire set of potential observations about which we want to learn is the population. And then we would take a data sample from that population, and hopefully that's representative. And that sample is a subset of the population that is collected and observed. So in business, we regularly collect our data samples, right? And we draw conclusions through our data analysis about the population after we apply this inductive reasoning. So the conclusion from inductive reasoning gives us degree of support, which is also known as inductive probability. So that degree of support is also called the strength of the inductive argument. So if we were 50% confident about the solution, then the degree of support is 50%. So we have two types of degree of support. We have the subjective degree of support and the objective degree of support. So the subjective degree of support is based on opinion, and it does not have statistical foundation, whereas the objective degree of support is a statistical foundation, and therefore it's considered more credible than a subjective degree of support. But both play an important role when we're interpreting and drawing conclusions from our data. So when you're evaluating assumptions, if it's through deductive reasoning, an empirical testable conclusion is made. We collect the data, we test the conclusion by comparing the observed outcomes in the data samples to their corresponding probabilities. We use inductive reasoning to decide whether the conclusion passes or fails, or we accept or reject the hypothesis. So if it fails, the transposition implies we must reject, but if it passes, then we do not reject. So here is our inductive reasoning for evaluating assumptions, right? So we have deductive reasoning that generates our empirically testable conclusions, right? Our assumptions, our methods of proof, and our empirically tested conclusions. For inductive reasoning, we test empirically testable conclusions from a data sample. So if the test fails, the transposition leads to a rejection or reconsideration of our assumptions. Selection bias in inductive reasoning. So improper use of inductive reasoning may lead us to inaccurate or biased conclusions. So the data generating process can typically be the source of our bias, right? Survey questions can be constructed in a leading way. So confirmation bias is the tendency to confirm our claim. Then we might have predictable patterns that are discovered. So we might have a predictable world bias, that is the tendency to find order when really none exists, and it occurs when people kind of read too much into the patterns from random data. And then selection bias is the act of drawing conclusions about the population using a selected data sample without accounting for the means of selection. And there are two common types of selection bias: collector selection bias and member selection bias. So collector selection bias occurs when the collector selects the members of the data sample in a systematic way. Availability bias occurs when the collector of the data sample selects the members of the data according to what is more readily available. Member selection bias occurs when potential members of the data sample self-select into or out of the sample. And this concludes our video lecture for reasoning with data. Thank you for watching.